A trunk is being pulled across a rough surface by a force P, producing an acceleration as shown. We want to find the value of P. We now consider the forces acting on the particle. We have the weight, 50g, acting downwards. Upwards there will be a normal reaction force. P can be resolved into a component to the right. This is next to the angle, so P cos 20. And upwards will be P sin 20. Since we're now dealing with a rough surface, there will be a frictional force opposing the motion. Remember, friction always opposes motion. And since the object is in motion, the frictional force must be limiting, which means it's equal to mu, the coefficient of friction, times r, the normal reaction force. Since the acceleration is all to the right, it follows the vertical forces must be in equilibrium. The forces upwards, the r and the p sin 20, must be equal to the weight downwards. So we can write down that r plus p sin 20 must be equal to 50g. We're interested in r, so r would be 50g. Take away p sin 20. If we now consider the horizontal, p cos 20 take away fr would be the resultant force causing the acceleration. Note that horizontally we have p cos 20 to the right and the friction to the left, but the object is accelerating to the right, so the resultant horizontal force must be p cos 20 take away fr. So p cos 20 take away fr is the resultant force, and this will be equal to the mass times the acceleration using F equals ma. We want to replace Fr in this expression. We know mu is 0.4, so the friction is 0.4 times R, and we have an expression for R. So we get P cos 20 take away 0.4 times R, and R is 50g, take away P sin 20 degrees. If we look at this, we can see all we've done is replace Fr by 0.4 times R. So this is still equal to 50 times 0.4, which is 20. Expanding, we get P cos 20 take away 0.4 times 50g, which is 20g, plus 0.4 P sin 20 is equal to 20. Keeping the p's together and taking out a common factor of p, we get p into cos 20 plus 0.4 sin 20, and that must be equal to 20 plus 20g. P is then going to be equal to the right hand side divided by the contents of the bracket. And this evaluates to 201 newtons, correct to 3. significant figures.